This week we'll dive back into our Jupyter notebooks and see how plotting is done using Matplotlib. So by the end of this video, you should be able to create bar charts, line charts, and histograms using Matplotlib. And you should be able to recognize the common components in a Matplotlib figure. So back into our Jupyter notebook from the last video. We already have a feel for what's held in the World Development Indicators dataset. What I'd like to do now is explore the CO2 emissions for the United States. To do that, I'll set up two masks using the string method contains that Ilkay introduced you to last week. The first will be a mask for all the rows for which the indicator name contains CO2 emissions. And the second is those rows whose country code is the USA. I'll keep the results of that data in a temporary data frame called stage. Let's check to see what's in our new data frame. What we have in our new data frame are all the countries are the United States, the country code is US, and its CO2 emissions. So it looks like we have the CO2 emissions per capita by year for the United States. So now let's explore how these have changed over time using Matplotlib. I can do this really in two lines of code. But what I'll do is I'll grab the years and then the CO2 emissions separately, and then I'll send those to a bar plot. Remember how I'd said in the last lesson that just a couple of lines in Matplotlib lets me create a plot for data exploration? This is a perfect example of this. I can see that there was a rise in CO2 emissions per capita from 1960 to 1970, and that's remained fairly steady since. The plot isn't perfect, right? I don't have a y-axis label, which is actually really important here. Without knowing what I plotted, this plot doesn't stand alone on its own very well. But again, that's okay if I'm just trying to explore the data. To make this graphic a bit more appealing, let's use a line plot. So I'll use plt.plot. I'll add the labels for the x and the y axes, and I'll add a title. I'm not sure if we need the x-axis label. It's pretty obvious that these are years, but we'll add it just for clarity's sake. And looking at these lines a bit more carefully, first, the plt.plot method asks for a line plot. Labeling the axes on the plot itself is called x label and y label. These are methods on the plot. Each of these functions takes a number of parameters, and you could change things like font size, color, and other things using those parameters. Similarly, we'll set up the title, and then we'll just plot the graph. So this is nice, but notice that the y-axis is actually starting at 15, and that could be misleading, as we've learned from the earlier lessons. So let's fix that by making a call to axis and passing it the ranges we want plotted. So I've already written this line of code, it's just commented out. What I'll do is remove the comment and rerun. The plot now is arguably better than the original bar chart, and it certainly stands alone better because of the proper labeling of the y-axis. Next, let's use histograms to explore the data. I'm going to plot all the CO2 emissions per capita values in our data set. But I put some code in here in the comments, which would let you just explore the values within one standard deviation. Sometimes it's helpful with histograms to avoid the data getting too spread out because of outliers, but let's go with plotting all the data for now. So let's have the hist data point to all the CO2 emissions per capita values in our current data set. And calling the dot values on the data frame gives me back the numpy ND array representation of that data. So I could ask for the number of data points using length, and I'll get back 52. Now let's plot those 52 elements using the plot.hist method, which is the call to create a histogram. I'm passing the method the ND array, then 10 for the number of bins. Then I'm setting the norm to be false to make sure it doesn't scale the data, and then I'm setting the color to be green. Then I'll label the axes and label the plot. What we get back is a histogram binning CO2 emissions per capita for the US. And this is really telling me that most years fall between 18.5 and 20, with some outliers. Now, if you find it hard to read, we could add back in the grids. So let me do that. So if I do plot.grid true and then re-show it, it's easier for me to get the counts for the number of years. Given that we usually fall between 19 and 20 metric tons per capita, I'm curious how the US stacks up relative to other countries. So let's pick a recent year where I have data for the US, 2011. I'll ask for the data where the indicator in the CO2 emissions is the CO2 emissions per capita, and the year is 2011. That should give me all the countries that gave us data over that time window. Nice. It looks like I got back what we wanted. We have different countries and their CO2 emissions per capita in 2011. Just looking at these values, 4.7, 6.9, 5.8, 5.3, I'm already suspecting the US might produce more CO2 per person than other countries. In fact, I probably would have guessed that before we got into this analysis, but let's see how this stacks up using a histogram. So how many countries do we have here? We've got 232. And that would include the US because I didn't do anything special to exclude the US. Now let's create the plot. Notice that I'm doing something slightly different at the start. Calling plot.subplots gives me back the figure and the axis separately. I'm going to use the axis reference with annotate. But before we look at annotate, let's look at the plot.hist call and see that we're setting up basically the same histogram as our last one, except this time we're counting the number of countries with a certain amount of emissions per person rather than the number of years. So let's see what this looks like. Wow, it looks like the vast majority of countries have CO2 emissions in the range of 0 to 10 metric tons per capita. The US at around 17 in 2011 is actually a real outlier. But where'd that nice label of the USA come from? This is one of those features we talked about with Matplotlib. It supports doing more complex things like adding annotations or lines to charts. If we go back to the code, we'll notice that I added an annotation of the string USA. I placed it at the coordinates 1830 and then drew a line from coordinates 1830 to 1805. There are more parameters to the annotate method if you wish to read the documentation more. But mainly, I want to show you this to point out, okay, sorry for the pun, that you can do more advanced graphics with Matplotlib. There are more questions I have about this data for now, but I'll leave you to explore them if you want. But before I wrap up the video, I want to point out that after just seeing a few of these figures, you've probably already picked up on the common features of a Matplotlib plot. So let's state them explicitly. The common features are the chart type, and here we have a bar chart. Next, we have the ranges for the X and the Y values. We have possible labels for the axes. We could also possibly label the figure itself and provide a legend. And then lastly, aesthetics like font size, line size, plot size, and even more complex things like annotations can be added. So now that we've seen all these features of Matplotlib plots, I encourage you to use this notebook, along with the others we provide this week, for more examples. But before we finish with Matplotlib, I want to explore the relationship between CO2 emissions and GDP. But let's do that in our next video.